There we go. So let's see. So yeah, I'll go through that again. We have the discussion that Chris started on GitHub around what we actually mean by interoperability. We have some questions around what the needs are for this spec for the kind of like non-whiteboard canvas tools, for lack of a better word. That's things like Stately and the systems that are less about drawing and more around kind of structured system diagrams and that kind of a thing. Some suggestions came up around kind of utility library support for helping people integrate this spec and do things like migrations as new versions come along. I did some work to demonstrate interop between Excalidraw and TLDraw, which we can touch on, although there's more that needs to be done there. And then a couple of the specific schema questions that I thought would be good to discuss are how we handle objects in a canvas in a tool that doesn't support it. So for example, if we have a tool that has freehand drawing and one that doesn't, what should that second tool show, if anything? Like, do we show the bounding box? Do we just show a point in space, or do you have a little message somewhere that says, you know, some shapes could not be displayed, whatever it is? There's some questions there. There are questions around freehand drawing. Some of that discussion happened on GitHub already. And then there's a kind of broader question around how to handle the locality of schemas. So one option, of course, is you have a base schema that applies to the kind of entire document and defines all the stuff within that. Another option is to have it more localized, where you have a base schema, but then you can also have further schemas, for example, for individual shapes. So you could have, for example, a kind of a base of shared interoperability, but then you might have, you know, two tools might have a support for a specific kind of shape with that schema, and others might not. That's everything on the agenda. How does that sound to everyone?
Yeah, fine for now, I think.
Sweet. I saw you speaking, Dragon, but you were muted.
Sorry, it was just a coworker.
Sweet. So I guess we can go through these kind of in order then. So I will also link to the discussion that Chris started. Is everyone here in the Discord, by the way? Or I guess I should ask if anyone isn't in the Discord. You don't have to be, but that's where we're currently dropping all these links. So yeah, there was this discussion started around what interop really means, which I think we can kind of take as, for this spec and its implementation in these different tools, what are the things that we actually want to kind of make assurances around? So, you know, one thing, for example, is what came up last week around not interfering with data that you don't understand. So if there's some extra shapes in a canvas that you don't know how to interpret, you know, choosing to, or well, making sure that you leave those alone for other tools to consume. But then there's, I think, harder questions around things like what are the visual properties that are important to preserve? Like, and Lou was talking about this on that same thread, right? Like these questions around text as an example, where it's probably fine for a different font to be rendered, but if, for example, the bounding box is changing, maybe that's going to cause problems. So let's see here. I will be trying my best to take notes as well, although might be hard to both host and take notes. So we'll see. So maybe where we can start here is just kind of getting some ideas from you all around what is it that we actually want to be preserving and kind of assuring interop around, and also maybe which things we explicitly don't care about or don't need to make interoperable. I think we have a small enough group to just kind of unmute and speak.
Yeah,
Or I can call people out. That's better. Go ahead.
Yeah. I guess the crux of that is called out in Chris's last sentence there, where he's like, maybe we need to look at the particular kinds of archetypes of canvases to help guide us in terms of what sorts of information. I think it was Jess last meeting, who pointed out that we may end up with two specs that are able to interoperate between them, project between them, because there'll be situations where visual fidelity and the presentation of visual information is the primary concern versus others where it's more structural or relationship or topology.
Yeah, that sounds right. I'm just getting up some notes here so I can turn this into a summary at the end. So maybe just on that point, or actually I'll put that aside for a second, but maybe after we get a bit more input here, we could come back to that question of what are the kind of archetypal canvas tools or use cases, because that might be a useful thing to think through. But anyone, feel free to unmute if you have thoughts on kind of what interop means and what we're trying to preserve in the spec between tools.
I was wondering actually that there also can be a difference between the open and safe format and the copy and paste format. They probably don't are the same. Copy and paste is just a small part of a whole spec.
That's definitely a good point, and that does connect to something later on the agenda around kind of how localized the schemas are, and I think maybe that is kind of a point in favor of having schemas at the shape level, so that you could do something like copy and paste, and you're essentially copying a fragment that includes the schema for just that object, and if the receiving end can interpret it, then that's good.
And is there a difference? I'm also building a visual programming system myself. I don't, in my system, I don't have a difference between the edges and the nodes. How is this with other? How is this for the spec or in other tools?
Yeah,
I need to know
so
the
for
difference,
example,
of course, but
for example, in XSkyDraw, we also don't have like separation between nodes and edges. Everything is just like objects on the canvas.
yeah, exactly.
So yeah, we do have arrows that specify kind of from which element to which element they go to, but they are like they would be according to like a spec of the arrow, right? It would be a separate object within the like the taxonomy, I guess.
Yeah, they have a type, but
yeah,
they are on the
Yeah,
same
exactly.
list.
Yeah. I think there's some really good questions around that, and I've been trying to think about whether there is some kind of fundamental distinction that can be made, and have really struggled to really come up with one that's not mostly arbitrary, in the sense that, you know, edges, like in Obsidian, for example, they do describe a relationship, like they are edges in the graph sense, but they're also visually shapes on the canvas, and so it's not clear kind of how that distinction can be drawn. The one distinction that maybe can be drawn is anything that is expressing relationships that is not itself visually represented. So if you have some primitive groups, let's say, but that group doesn't actually have any visual representation, then maybe you could make the case that those are kind of ontologically separate from the objects on the canvas. But I'm unsure.
I think that was one of the more fascinating things that I learned from both the TL-Draw and the Excalidraw folks is the notion that in their world, even the things that they do have, relationships that they maintain long term as you move around, these connections between things are maintained because of the richness of the thing that they were encoding into an edge. They don't represent it as an edge. And I think why most of these pieces of prior art do have that distinction between the node and the edge is to have a normalized regular interface for saying like, hey, this is the thing that's expressing the relationship. And here's how that can be predictably inspected and applied. And so I wonder if it's less a situation where we don't want nodes and edges, but maybe we need more rich edges. Maybe it's the is-a versus has-a sort of thing. Do these special kinds of nodes have relationships? Is that something we should express as subordinate to the node rather than as a peer? But I think there's something hidden in this realization that we're seeing across those two pieces of prior art and even the visual programming example that was just called out too.
Right.
I think what sorry.
Go ahead. Was that Max?
I think what's fascinating in these canvas tools is that they're both visual and structural, and some are more on the drawing side. And if you take it to the extreme, you just have a 2D vector drawing program. And if you're at the other side, you just have, I don't know, an ontology editor. And in between, you have these canvases. And they have vector drawings. And for some of them, they understand the structure and also know which vector drawing represents which item in the structure. And then they might also have some additional structure. So it's really maybe these both worlds, visual stuff, structural stuff, and some mappings in between, which somehow need to be represented in the data exchange format. So this would also resolve the edges. So you have a visual object representing a drawn edge, and it maps to an edge object that actually has some semantics. Or maybe it doesn't. It depends on the tool that created the edge. So it's not restricting the user that edges need to have semantics. But somehow you have these both layers and they might be connected or not.
Yeah.
My feeling on an edge is that it's its own object, but in general, it's just an object that depends on one or more other objects. So it's an object with a dependency on other objects. And that's how I've done them in the past.
Yeah, I have a similar feelings about this, and like in general, I think if you have like a graph of nodes and edges, you can kind of transform it into a graph consisting of nodes that represent both nodes and edges in the previous. So like I think both of those, only having nodes without like having edges represented as a separate data structure in the format, or having them like they are both interchangeable to some certain degree, right? I think the importance here is do we want to call it out in the format as a separate entity? What advantages might it have over not doing that, right? So I think we can think about like what may be the reason to have edges as a separate, like if there are any specific things that maybe, I don't know, help with optimization or with some algorithms.
Go ahead, Dragon.
Thank you. One thing that came to my mind, and it was mentioned, like edge is just a thing that references two or more other objects that exist in the space. How far maybe we should take that concept and like have each of the properties on the object just be a reference to something else, like color of an edge is just something that references the concept of grain color. So can we just like relate everything even at the level of individual properties? Does it make sense?
I think that might make. Oh,
Go,
Go ahead.
go. I wanted to say that
Go-
I definitely think that it might be very interesting to have like references. And what you said, I don't know if I understood correctly, but what it reminds me is Open API and like referencing, like you have a map with general entities and you can reference things from different places to different places. That's kind of how. So like, for example, I had 5 shapes and all of them have the same color, and instead of each of them having hard-coded the same color, they are referencing like one thing that is like an abstract color variable inside like a color node variable or something like that. Is that correct? Yeah, okay.
If
Well,
I
if
can
you-
also oh, so go ahead.
If you go that path further, you end up pretty much with a copy of RDF. Very, very fine granular. Everything can relate to everything. It's cool, but also it's so generic that it's hard to use for anything in particular.
Yeah, definitely.
What we also have in biology is edges on edges. So if you take that to the extreme, you have objects, they can have a visual representation, and then you need something like a structure that can say, well, this object actually depends on these 2 other ones because it's more or less, this is really an edge. So some structural primitives are needed besides just having these entities.
I think one distinction that we might be able to leverage here is that part of what kind of unifies all these canvas systems is the fact that they have some underlying set of addressable objects, whether they're on the canvas or not, which is not the case elsewhere, right? Like if you look at the DOM on the web, part of reference there is often structural, like it's like, you know, the second child of the element with this ID or something. And so one way that we can make a pretty kind of formal distinction between just kind of regular objects and stuff that is kind of relational in nature is that the relational stuff has to refer to those other objects on the canvas, whether it's like an edge, like a binary edge or a hyper edge, or it's some other structure that's expressing relationships. Part of how that must be defined, or at least the most kind of straightforward implementation of that requires that definition include references, which is something that we could also pick up like pretty automatically, right? Like you could look at a shape or an object on the canvas and be like, does this include the IDs of other things? In which case it is in some sense like a relational object.
I was wondering in general, how close do we want to get to like a DOM object model in a sense, right? Because we could kind of use XML and call it a day, more or less. But I don't think that's the point. However, there is a lot of, like, for example, DOM is obviously by structure tree-like, right? Is this something that we all agree on, that we want to keep the structure of the file flat, for example? Do we want to allow for like actual embedding within like actual children inside JSON? Like, I mean, like actual subnodes inside of nodes, or do we want to like just using references, right? Okay, we have one basically array with all of the objects, and if one object relates to some, like for example groups, right, or tables or whatever we want to do, we use only IDs, right, not embedding the entire nodes inside. This is pretty like I think everyone agrees on that.
Well, for my the tool that I'm building, that would not be enough to have one flat list, even with references. I think I'm thinking of, for example, the state machine, which has or state chart is a better example, I think, which can have multiple state charts as children, and even deeper. And in that situation, you need
Yeah, but
the
when you
nodes
say
inside it.
when you save, I think for me the idea is just to have a checkpoint of the whatever scene you have, so you can flatten it when you export it, so it's easy to pass around. Because I think what's the goal at the end? Like if you have a visual programming environment, you have boxes and arrows. Why do you copy it to TL Draw? It's just to make it nicer and edit it with the colors and the text or something like that. So I would be really practical, and where it would be really, for me at least at first step, it would be like a checkpointing. You just more or less dump and flatten your scene, because you don't know what the other person is going to do, or you have to export it separately. If you have some diagram, maybe you export them independently or something like that. And for instance, the coordinate system, when I export it, I kind of reset the coordinate system, because when I select a group of objects, the bounding box of the group determines the coordinate system of what I export, for instance. So I can drag and drop it any place into a new canvas, and the new coordinate system would be the one where I drop it and something like that. So yeah, I would keep it as simple as possible for me, and even the edges is just, yeah, there's an edge to be drawn, but what do you want is like the two boxes still move together, or they are still attached in TL Draw, for instance. Because TL Draw, like arrows, changes every week. They fine tune the arrow system every week, and it's like perfectly tuned and stuff like that. So I don't think you can encapsulate that in the file. You really want to let the tool do their best. You have to draw an arrow between those two boxes and do what you can, or if your tool doesn't draw arrows, you ignore the arrows and stuff like that. So
it does seem like if you have, say, a state chart or something, right, and you need these like subsystems to be contained, that you, at least in principle, you can express that relationally, where you have your node, and you're like, okay, this other cluster of nodes and edges is a subset of this node, for example.
That could be like the frame system. Is it in Figma or something like that? So basically, you have a series of groups of objects which are independent, more or less. Maybe.
I think one important part of that, though, is this question around kind of like coordinates and kind of coordinate systems. And I think it's maybe worth distinguishing like a couple of different kinds of grouping primitives that we have. One is where you, for example, select some shapes and you put them into a group, and then all of the shapes in that group are now kind of, their coordinates are relative to their parent group, right? So if you rotate the group, everything inside is going to move with it normally. That's different from the kinds of groups where it's just basically just a set of objects, and you're saying like, here is just a bucket of objects on the canvas. There is no other kind of affordance given in terms of like UI or UX by default. We're just making this bucket so that we can refer to the bucket as a whole, which would, be enough potentially for defining some subgraph, for example, and being able to refer to that as a child of another node if you wanted to kind of encode those semantics.
What I think should be possible to express exactly what you were talking about now is like just having two types of links between nodes, to call them that way, and like one type kind of just takes the geometry, the transformation as they are, versus the other one kind of takes it from the parent and then kind of builds on top of it. It seems that like in principle, you should be able to kind of represent that in correlation to the edge between the two objects.
Could you just explain that one more time? I didn't quite catch that.
So if one wants to represent a relationship where a child object is in kind of relative coordinate space of a parent, having one type of edge for that, and for a child that is kind of independent in the absolute coordinate space, then like a different kind of edge could signify that. Again, at least in principle, I'm not sure if like that would be the way.
Right. Yeah, I think that makes sense. And part of this is also a question around what is encoded explicitly in the spec versus what is kind of some level of coordination around expected behavior when you're interacting with these things. It does seem, at least at first glance, that something like groups or those kinds of coordinate changes where you're making something relative to something else should probably be like a spec level thing, because if one tool expects, you know, coordinates to be relative and one doesn't, that's gonna break everything. But it might be that those like those could either be explicit relationships relating to those kind of coordinate relationships, or they could be a part of how like a type behaves, right? Like if you have a type that is a group and it has a bunch of, you know, references to some member nodes or something, then maybe that's part of the like how that's implemented. I'm not sure if that quite made sense, but yeah.
Maybe it also makes sense to simplify and just say everything is absolute and we have groups, and the importing tool then might convert it to relative coordinates if required, just to not have every edge case in the format.
Also, one thing that Dragan, I think, mentioned that gave me a little bit of thought is that we don't really have parent-child relationships, right? Since we are not, there's no such, we cannot define it. I mean, at least currently the way I see it, for example, in Excalibur, we have this flat structure. There isn't really such a thing as a parent-child relationship, right? Because one element, in theory, can reference many other elements, and like this is not one-to-one, and you know, a child in theory could have its parent inside of it. So like, I think standardizing this would also maybe not standardizing, but you know, this is like thinking about this as parents and children is, I don't think, not really defined currently yet, right? So that's
Yeah,
also
and
something that would
it does seem like any attempt to define a kind of like exclusive parent-child relationship is going to cause problems, right? You can still have, for example, an edge that is a child or a parent edge, but that's different from enforcing the lack of the inverse, right? Like a child having its parent as its own child, which like doesn't make sense semantically, maybe. But it feels like it would be problematic to try and enforce that, because then you're getting into actually enforcing like a very specific ontology of like how the stuff in the canvas can be structured, which defeats the whole purpose of this effort.
Well, in Excalibur, it would just be a group, and the children would be the things in the group. So that's how you currently have parent-child.
Yes. I mean, we do have groups, and we have frames as well, and they do reference each other. However, I don't think that this is necessarily spec thing. Is more like implementation detail in this particular case. I don't think it should be spec. Maybe, I don't know.
Well, if you import stuff and then move stuff around and other stuff moves with it, that's a great feature to have. To not have everything move around, but some parts, and that's actually exactly this grouping you have. So that maps maybe a little bit to the other groupings in other canvases.
One thing, so we're, as far as I can tell, we're also talking like, should we enforce certain types of relationships and like relationships altogether? And it seems that it was mentioned in that GitHub discussion, like visual fidelity doesn't tell anything about topology or anything like that. And it seems to me that if somebody is talking about, say, pixels in a PNG image, it's basically like each pixel is a node that is completely independent of all the other pixel. It's like not enforcing any kind of relationship between those tiny objects in this case. And in general, it seems that canvases don't have to have any links between them. Like all the objects can be completely independent. And to also connect to a comment, I think it was Max, like if we go to a specification that where everything is linked, such as RDF, and kind of on the other end of the spectrum, something like raster images where everything is completely independent, it seems to me that like we might be looking for something in between, that we get some sort of semantics and some sort of rules and dependencies between different concepts, but like try to make it sensible and for different tools to be able to cooperate.
Yeah, I think the result will be something like a visual part of the spec for vector drawings and bitmaps. Just where is what and what does it look like? And then a structural part or graph-like part, how are things connected structurally? And then a link between them. Actually, this thing in my graph is the thing with a rectangle, and this thing here in the graph is actually the thing with the circle and the squiggle line. So then you have three parts, the visual part, structural part, and the mapping. And no matter what we do, I think we will end up with something like this.
Yeah, I strongly agree. I think in terms of talking about those sort of RDF triples, it's a question like, what are the predicates that are relevant to the set of common relationships that we want to express and manipulate and share across these tools?
Yeah, to the point around finding a middle ground between these, I think the kind of naming those two sides as something like purely visual and purely structural is quite useful, because I feel like what we're trying to shoot for is to have a spec that kind of occupies like the middle 90% or so. So if you're entirely on the visual side, then maybe like bitmap, like all the stuff that you'd use in something like Photoshop makes more sense. And then on the other extreme, you have something like RDF that is purely expressing kind of relational structural stuff, and we want to have a spec that can go pretty far in either extreme, but also like mix them together, so that a tool that is almost entirely visual can coexist with a tool that does express more structure, and that a tool that is much more structural, like a state chart tool, can also interoperate with tools that you can scribble on. Go ahead, Dragon.
I'm wondering, do we have any reason to believe that there is only visual and kind of that topological aspect, or should we be suspicious that over time there will be a third and fourth and fifth way that is semantically meaningful? If that made sense.
I don't know the answer to that.
Yeah, like auditory, for example. Yeah, okay. I mean, yeah, I mean, okay, now that I started thinking about this, like imagine you have a graph of things, and as a visually impaired person, you want to have an order in which like the software reads it to you, right? That's also like another. Yeah, I think I understand what you mean, Jan.
That does also raise a really important point that we should probably table for a future discussion, but really making sure that this spec is built in a way that is accessible, not necessarily out of the gate, but that it encodes the information that is required for tools like screen readers and other things, and potentially the kinds of things that you could have browser support for in the future, I think is really important. Which I suppose is mostly going to be for visual impairment, although I'll happily claim plenty of ignorance around how to think about accessibility there.
Also, one more thing is that, like, I think every tool, someone correct me if I'm wrong, but currently every tool is more or less 2D plus Z indexing, right? Some ordering to the elements. I can see a lot of use cases for like canvases that are not bound to only 2 dimensions, right? But also three-dimensionals with like things like VR becoming more and more approachable. While I don't think anyone here represents a product like that or an app or a library like that, but it could be something to look into in the future as well.
Yeah, I think the way we're going, it should be fairly trivial to include that use case in the spec, where the main difference is that you're obviously using a third dimension for your coordinates, and that something like Z or like depth ordering doesn't really apply in the same way that it does in 2D. But as long as we're not enforcing something like Z ordering as a kind of first class part of the spec, then I think people will be totally fine to use this for a VR or AR application.
Yeah, I think that's the part that's been evocative about Apple's spatial computing terminology, is that sort of overlap with the spatial canvas thing and the notion of these being tools for thought, and imagining a scenario in which we're in AR, XR contexts and can, explore that information in those ways. And to that extent, it was really interesting, the suggestion there. I'm wondering maybe three-dimensional objects or auditory sources are just more objects that could be expressed within this graph or hypergraph. So as long as we've made it flexible enough that those sorts of objects could be expressed with their unique properties, we had that kind of property back thing you suggested, I think this could scale. But that's definitely a wonderful idea to keep in mind.
Yeah, I think as has been pointed out, no one here is kind of representing one of those tools, but I definitely think it's a useful kind of mental check to test whether our current thoughts would extend to that and be flexible enough to do that. And then if they're not, then we're potentially doing something, or like potentially making a mistake in kind of the thinking around the spec. So we have about 15 minutes. We've, I think, covered like a good 2/3 of the stuff on the agenda, the important stuff. Let's see here. So one of these points is really just a very small aside that I don't think warrants all that much discussion yet. But I was talking to Jess, and the idea came up for kind of developing like a utility library that can be used for this spec for things like validation and potentially schema migration and that kind of stuff. I don't know what like languages are being represented. It seems that most of these tools are based on some kind of web stack. So like starting with a TypeScript library could make a lot of sense. And part of the motivation there is that it gives us a point to coordinate around, and ideally turns into something that is a kind of a labor saving thing, right? Like that it can actually reduce the amount of work that cool authors would otherwise have to do entirely themselves. And I think hitting that bar would be a really good one to help kind of incentivize adoption of a spec like this. So I'll mention that as a thing to come back to in the future. It's not a need that we have right now, but I think it could have some like strategic benefits to pursue. Oh yeah, I'll also mention there is a repo up on the org now for TLDraw, Excalidraw interop. I didn't get as far with that as I would have liked. I basically only got the two sides kind of up and running. But I think now that the like all of the work to do the work is out of the way, there's only a few hours to get something basic going there, so we can look at that more asynchronously.
So sorry, what does that consist of? Does it mean there's example files that
So
both tools are loading, or?
So the kind of the experiment there, or like the design of it, is that we basically have we have two clients for TLDraw and Excalidraw, and then they're both reading and writing to a file. I mean, they're going to be going through a server so that we can kind of manage the reading and writing of that file safely. And we're basically going to take a JSON canvas-esque spec to kind of expand out interop between the two as far as we can go until we kind of hit a lot of friction, and hopefully we can get some kind of informative results there. It's basically just a fork of the very quick demo that I chucked together for the TLDraw Obsidian GIF to post on Twitter.
Yeah, I see there's a test.canvas file. So at some point it would be interesting to see if people wants to share their test files, and we can try to load them up in different software. Because I started producing some too, but yeah, I'm really curious to try to load other people's.
Yeah,
once it gets more concrete.
Exactly. In like a couple months' time, when we're kind of at that stage, then I think building out data sets for test cases would be a really valuable thing to do. There's two more points on the agenda that I think would be good to touch on. I'm sure much of this stuff will turn into more future discussions, and we'll organize how we do that async. One is a question around how we think objects that are kind of unpassable by a tool should be handled, and what is kind of required or desired to make the handling useful. Like, for example, does a tool need to know or be able to compute bounding box information to kind of usefully display the space that a shape occupies, for example? And then the other one, and I think we've maybe already moved in a direction on this, but it's the question around how we do kind of schema scoping, and whether it's sufficient to have this kind of one root level version schema, or whether we need to get a bit more granular. It feels like a lot of the stuff we're talking about is easier and perhaps even requires that more kind of granular schema, like the example of copy and paste, where something needs to know, like you can't just paste a fragment of like a shape that just happens to match, but like but is something entirely like its type might have the same name, but it's version 1 as opposed to version 6 or something, and then it's going to be passed correctly but interpreted entirely incorrectly, or whatever it is. So maybe some granularity there makes sense. The other thing that can get us is kind of a more, I'm not quite sure like how you would describe it, almost like a kind of federated interoperability. That's really not the right word, but what I mean is that you could have a kind of a base level of shared interop that's incredibly wide of just the underlying core canvas spec. But then if a group of tools that were, for example, doing state chart stuff wanted to have, maybe they had like a couple of shapes and a relationship that they needed to express that was like really specific to that use case, that they found incredibly useful, and there was basically the same thing across those tools, then they could independently kind of standardize that themselves into a very small kind of spec fragment of sorts, and they could share that so that they'd have that more kind of local interop for more specific things, while having that broader interop for the rest of the tools.
Yeah, I think that resonates. I mean, ideally, the core spec is in line with the rule of least power, looking to Tim Berners-Lee's learnings from HTML and why that scaled and why that continues to exist. But I think there's something interesting there at like the object level of almost something akin to how MIME types, enabled that kind of alignment around a particular object type or data type, or how that is interpreted or transformed or ingested by different sets of tools that care at that level of fidelity about that object.
Yeah, it also matches other really successful kind of examples of protocols, like how email has this kind of relatively small underlying spec, in the sense that you have, only 2 or 3 kind of strictly required fields, but then clients over time were able to extend that for, like rich HTML rendering and that kind of stuff, which have incrementally become standard, but they weren't standard in the sense that they were imposed in the core spec. They kind of came out of more local coordination because the underlying protocol was able to be arbitrarily extended with other additional data in those emails.
Yeah, I kind of want to second this sentiment, as in general, I think that not all the tools have to support the same features. That's definitely, I don't think, anyone's goal here. I mean, it would be amazing, right? But like, we have to be realistic. But at the same time, it would be nice to have those paths of kind of, I don't know, what comes to my mind is progressive enhancement, in a sense that, let's say someone wants to make a library that is perfect at rendering like mermaid diagrams, or only things that mermaid supports syntax, mermaid syntax supports, and then you kind of export from that program into another program that allows you to, I don't know, add colors to things, or maybe scribble something on the side and stuff like that. So I definitely think that this idea of having like this global, like this kind of top level spec that is defines like very base level things, and then like specific shapes or objects have separate specifications. I think that's something that would work really well, for example, for Xcoredraw.
Yeah, I think that makes a lot of sense. This is not particularly relevant, but I'm just kind of thinking of like this mental model of how we're trying to take the kind of some like middle ground of sorts, and realizing that, and this is kind of obvious, but I'll just say it out loud anyway, that there are some things in there that are going to be they're going to kind of cover the whole thing. Like the need to uniquely address objects applies to visual tools exactly the same amount as it does to stuff that really cares about its topology. But then something like whether something has explicit coordinates or not is something that kind of towards that kind of more structural end becomes like a question. And so I suppose that'll be where some of the harder decisions will be, of kind of where to draw that line on the edges there. But yeah, I think that broad goal of having the core spec be really just the most widely shared basis, and figuring out what that is going to be kind of the most important thing, right? Because if we get that right, and we get the kind of extensibility affordances right, then we've set it up to be able to evolve over time. Because I think it would be insane to think that we're going to kind of nail something that should never change for like a decade and get it right. That's just a bad way to do this kind of stuff. And I think like one question there for me is around coordinates. Like is is that like a required field basically of the spec? Which I guess a different way to put that question is that something that you leave as a core requirement, either or an optional requirement, and then do you deal with that as like on the implementation side of, because you could go either way and still have kind of mitigation strategies for whichever way you went. If you had a tool that didn't require those explicit coordinates, they could just be kind of required to provide, you know, they could just put everything at 0 or something, some default fallback behavior. And you could also do the same thing if you could have explicit coordinates and then a tool that didn't need them could ignore them or, you know, produce them. My inclination with a lot of these things is to lean towards making them optional, but I think it's probably also possible to go too far in that direction. I'm not sure if people have thoughts on if there's a really good solution to kind of optional versus required coordinates or like explicit coordinates.
It's really important. Go ahead.
Yeah, are you thinking about a tool like if you're laying out a graph, you might have to do force-directed layout, and then if the coordinates aren't in the document, then anything that opens it up has to run this really complicated layout algorithm to even show it.
Right.
So it could be useful to have a suggestion there from the tool that knows the information to be in the file.
Yeah, I would favor too to make X, Y, width, and height to be mandatory. So at least if I don't know how to render the node, I can draw a box and then ignore the rest. Because yeah, if you do a graph algorithm, at some point you have X, Y coordinate. Your tool calculated X, Y coordinates. So when you dump into a file, just put them there. Then the tool can ignore them if they want to, but I think as a external tool like TLDraw wouldn't know what to do. You would have a stack of boxes at 0, 0. So I think X, Y width height for me would be really mandatory. But
yeah, I feel like this is the heart of the wicked problem here, that if you're imagining a tool that lets you maybe copy some structural relationship information from a programming language, like a entity relationship, or even just the property, class diagram of that thing effectively by just its description of its relationship, paste that into a visual tool that's able to say, I see these things are related. I'll render that in the structure that ends up appearing as a ER diagram or as a class diagram. You have the complexity there, like, do you want a constellation of tools that each have unique things that they're capable of doing from this format? But then how do you show that outcome? Like if I have a TLDraw thing that I export and I bring that into Excalidraw, are they going to agree on exactly the font spacing, layout, it's and fidelity there? And how difficult do you make it to enter any new tool into that space if they have that burden of getting to that perfect level of renderability? So it's the heart of the wicked problem here.
Yeah, let's go Dragon, then Max.
Just in that example of the force-directed layout, I think the information that allows you to reconstruct the state is not the coordinates itself, but kind of the initial conditions and the kind of algorithm that was running to get your layout. And so like you have a point in time that you are trying to kind of copy between the two tools, and coordinates are just like, one current derived state from it. So like maybe there are different representations to get you to the same output, but I actually would stay away from like requiring coordinates specifically, because again, maybe there is a different type of representation. And just to maybe also like give an example, like if the force layout algorithm is still running and you copy an intermediate state while it's still not settled, you then copied something that like might end up looking a bit different in a different tool if it's still running its own layout algorithm. So just some thoughts.
If we have items that are not visible, then they don't have coordinates. So obviously we then allow items having no coordinates. And then a visual tool having no coordinates can choose to either put them all on top of each other, run sophisticated layout, or just don't show that item because it has no coordinates. So it makes exchange between tools super easy. And if you have coordinates, whether derived or hand painted, just put them in because it makes interop easier. So make them optional, but put them in whenever you can. Would be my suggestion.
Yeah. And I suppose that would extend the same to 3 dimensions there, where you're just sorry, specifically, well, it would extend to 3 dimensions, but then also that question of kind of width and height as something desirable to have, like a bounding box or something. If we go that route, then that would extend as well. So your kind of bounding box representation or whatever that would be would just match the number of dimensions you have, which, at least to my mind, it feels like it's probably just 2 or 3. I don't know if there is a point other than kind of being completionist to have 1 dimension as an option in there where everything is just on a line. I don't know.
Well, even if you have 3D, just put in X, Y, Z, and if the 2D tools
Yeah.
imports it, it just drops the Z or uses it just for Z ordering. Something will come out that might be useful, maybe not. I mean, that's fine.
Yeah.
So maybe
go ahead.
So maybe at least my model currently was that there's like this array of like vertical objects, but then we kind of stumble upon those horizontal things, like for example, positioning, right? So maybe it's worth kind of specifying them. If you have position, then like you're going to follow this kind of specification, right? If you have a bounding box to provide, then it has to follow those certain rules, right? And that could, like, those horizontal things could extend well into, like, for example, ordering, right? If you want to present all of the nodes in certain order, then you do this in this way, right? So those kind of horizontal that go across all of the possible objects / node types that you have, maybe it's worth like thinking about it that way.
So I've noticed that we are running overtime, so maybe we can just end on a few notes. Happy to keep chatting for a bit, but I just want to be respectful of anyone that has to head off. So as part of this, I'll obviously chuck up the recording, the transcript, take some of these main points, put them into the summary, and then either out of that or beforehand, people can feel free to start some discussions. I'll definitely make at least a couple there. See, are there any other admin-y notes that I should hit on before we wrap up?
I had a question about,
yeah.
So I think it was mentioned in one of the GitHub discussion about the file nodes. And in our tool, we use a lot of external files. So we have like PDF and CSV file and GeoJSON and images and movies and stuff like that. So at least a minimum, it would be nice to have the either a type or MIME type stored into the file node. And then
right.
So it looks like it's very vague description about, is it a URL or is it a local file? And so then if it's local files, how do you manage those local files, those assets which are external to the files? Like there's different tools, so people just hope to load the asset in the same folder, so there's path, and then it gets really annoying because between the platform, some file format describe are basically a zip folders with all the asset inside. So there's different ways to manage the assets. Right now, when I did some tests with exporting, I just put public URL to everything, but I don't think it's really scalable to share files that way. So
yeah, that's a really good point. I've added that to the notes. And that second question as well, I think, is really important, of not just how we do robust asset handling or external references, but how to make that portable in the cases where you really want that. So having something like that option of being able to package up the things you're referring to in a kind of automated way, and be able to unpack that on the other side, like including a bundle of images and other assets with your canvas file.
But right now, yeah, for me, the blocking one was the type, because almost all our nodes are assets. So if I don't know what the URL is pointing to, it's really, really annoying to have to discover dynamically, is it a movie or is it an image, and then build the representation.
Yeah, I'll add that to the notes as well. So around assets, we have the question of how to do assets in general, how to make them portable, and how to have proper kind of typing on those assets so that we know how to interpret external data.
And then quickly, there was the drawing nodes that was mentioned in the discussion on GitHub. And for me, the only experience I have with drawing is using Perfect Hand Draw tool from the TL Draw guys. So that's what I use to store the information as an array of points. But yeah, I don't know if there's other, because very quickly you go into like SVG or if you want something very complicated. So I don't know if people have ideas on how to store hand-drawn notes or drawings.
I mean, I want to be respectful of time. Like, this is a topic that's very deep for me. I'm working on like freehand representation and how to store it and how to draw it and things like that. So that's definitely, there's a lot of ground to cover there, and we don't have time.
Yeah, and
Right.
it could be ignored at first. We can say
Yeah.
maybe 2.1 or something like that. And
I suspect that the the number of tools that kind of want support for that is big enough that it is something that we should include in the first spec. But I think the amount to discuss there is definitely we'll have to wait for a future call. But I think it's part of there's a broader question there around not just freehand specifically, but kind of geometric information like paths and so on. Or kind of the enclosing geometry of a shape that isn't a axis aligned bounding box, that kind of stuff. So there's questions there for a future one. We're a nice 10 minutes over, so thanks everyone for sticking around. I will end the recording now. Doesn't mean we have to head off, but let me hit this button.